Hello everyone, today, I'm excited to present our work from easy to hard, the MIR benchmark for progressive interleaved multi-image reasoning. Let's start with the motivation. Current multi-image benchmarks tend to overlook interleaved textual contexts and neglect the distinct relationships between individual images and their corresponding texts. However, in real-world scenarios, we often need to reason jointly over multiple images and their interleaved text. For example, when comparing visual scenes, analyzing temporal changes, or understanding spatial relations. To bridge this gap, we propose MIR, a new benchmark specifically designed for multi-image interleaved reasoning. The MIR benchmark contains over 138,000 images and 22,000 annotations. It focuses on 3 primary categories of reasoning, which are further divided into 12 subcategories, covering tasks such as spatial, sequential, and analytical reasoning. The spatial categories includes 3D view, depth relationship, image puzzle, and forced perspective. The sequential categories includes cooking process, speed comparison, location relationship, and motion detection. And the analytical categories includes scale blur, weight comparison, chart analysis, and yes but satire. Furthermore, each instance in MIR includes explicit reasoning steps, including summary, caption, text to region to region, and conclusion. This enables models to better associate visual regions with the corresponding text and connect logical clues across multiple images. Building on these structured reasoning steps, we introduce a stage-wise curriculum learning strategy, following an easy-to-hard learning paradigm. We use an expert model to split the dataset into easy and difficult samples. After fine-tuning on easy samples, we sample 40% of difficult ones for multi-stage curriculum learning. First, we combine the question with summary, caption, text to region, and region to region as input to generate the conclusion. Next, we move region to the target output, then add text to region from the question, followed by the caption, and finally the summary. The goal is for the model to autonomously generate a full reasoning process from the original question and arrive at the correct answer. During this process, the model progressively learns to move from generating only conclusions to producing the entire reasoning chain, effectively enhances both the reasoning depth and the generalization ability of multimodal large language models. We conduct comprehensive evaluations of the original MLLMs, the fine-tuned MLLMs, and the MLLMs enhanced with our proposed method across multiple benchmarks. During in-domain testing, fine-tuned models achieved a 3 to 5% improvement, while our stage-wise strategy further increased performance by around 7%. In out-of-domain settings, our method yielded 1 to 5% gains over the baseline, surpassing traditional fine-tuning, which achieved only about 2%. Through experiments, we have discovered some interesting phenomena. First, the ability to follow instructions is critical for stepwise curriculum learning, as stronger instruction adherence enhances the effectiveness of the learning process. Second, the model shows the least improvement in performance on sequence tasks after fine-tuning, which may be attributed to the fact that the images in sequential tasks are extracted from videos. These extracted images often fail to accurately represent the entire video, leading to the model's suboptimal performance in sequential tasks. Here's an example of our method in the case study. Our model follows a structured reasoning pipeline. It clarifies the question intent, analyzes the image, localizes the target region, links visual relationships, and finally derives the correct conclusion. These results demonstrate that the MLLM trained with our method is able to maintain a structured reasoning pipeline, enabling it to produce more accurate and logically consistent answers. In summary, MIR provides the first large-scale benchmark for interleaved multi-image reasoning with explicit reasoning steps, and our easy-to-hard curriculum strategy significantly boosts reasoning and generalization across multimodal models. we believe MIR will inspire further research on cross-modal reasoning, scene understanding, and complex visual text analysis. Thank you for your attention. I'd be happy to discuss more details or show you some examples from our dataset.